Question number 25. In the xy plane, a circle has center C with coordinates h, k. Points A and B lie on the circle. Point A has coordinates h plus 1, k plus square root of 102, and angle ACB is a right angle. What is the length of AB? So first of all, there is no diagram given with the question, but if we have to draw it, we will first draw a right angle triangle inside a circle to just see, because it says that a circle has center C. Let C be the center of the circle, and this has the coordinates h, k, the center. Then points A and B, they lie on the circle. So we can just mark A and B like this. And point A has the coordinates. So this one h plus 1, k plus square root of 102. So this is given for coordinate A. And angle ACB is a right angle. So what is the length of AB? So we need the length of this one. So first of all, you can see that A and B, they both lie on the circle with center C. Therefore, AC and BC are both radii of the circle. That means AC is equal to BC. The sides are equal. So if the sides are equal, even the angles will be equal. That's why I marked it as a 45, 45, 90 right triangle. Because if sides are equal, it will be a 45, 45, 90 triangle in a right angle triangle. So AC is congruent to BC. AC is equal to BC. In other words, congruent or equal. So the length of AC, or the distance from A to point C. So this length A to point C can be found using the distance formula, which gives the distance between 2 points. Now what is the distance formula? So if you have 2 points x1, y1 and x2, y2, the distance formula is given with square root of x1 minus x2 the whole squared plus y1 minus y2 the whole squared. This is the distance formula. So you have to memorize this. Now we will substitute the given coordinates of point A. So point A's coordinates are h plus 1, k plus square root of 102, and this one we will use as x1, y1 in the distance formula. And the coordinates of point C, that is the center of the circle, which is the same as the right angled triangle point, h, k. So this we will substitute for x2, y2 in the distance formula. So once we substitute this, what we will get? We will get square root of h plus 1. So we are subtracting the x coordinates, minus h the whole squared. Then we are subtracting the y coordinates, k plus square root of 102 minus k the whole squared. So when we do this, the h's cancel and even the k's cancel inside the parenthesis. So we are left with square root of 1 squared, which is just 1. Square root of 102 the whole squared, which will be equal to 102 itself. So this will be equal to square root of 1 plus 102. So after that, we will add 1 plus 102 and get square root of 103. So that means the length of AC, what we calculated using the distance formula, is square root of 103. Now we know that by the Pythagorean theorem, if a right triangle has a hypotenuse with length C and legs with lengths A and B, then now we will apply the Pythagorean theorem. A squared plus B squared is equal to C squared, where A and B are the legs and C is the hypotenuse. So if we substitute square root of 103 for A and B, because both AC and BC are equal, that will help us to use the Pythagorean theorem and solve for AC, because that is what we need. We need the length of AB. You can also use the special right triangle S square root of 2. That is, if S and S are the sides, S square root of 2 will be the length of the hypotenuse. But let's say we use the Pythagorean theorem directly. Square root of 103 the whole squared plus square root of 103 the whole squared will be equal to C squared. So this is 103 plus 103 is equal to C squared. So 206 is equal to c squared. So 103 plus 103 is equal to c squared. So 206 is equal to c squared. Taking the positive square root of both sides of this equation. Now we have to take the square root. C is equal to square root of 206. That is matching to answer choice A, square root of 206. So if in case you want to apply the special right triangles formula directly, that also we can do. So S root 2. For a 45, 45, 90 right triangle, this is actually given even in the reference section, as you know. So we know that square root of 103, square root of 103 is the S and S. That means S square root of 2. If you take square root of 103 and multiply it with square root of 2, what we will get? We have to basically multiply the terms inside the radical sign. So we will get square root of 206. This way also you can use, using the special right triangle, the relationship between the sides in a special right triangle, which is the 45, 45, 90 right triangle.